Hey guys, welcome back to another Algebra 2B video. Today we're going to talk about piecewise functions. Piecewise functions, they're weird. I'm not going to lie. They're not hard. These are functions you really haven't seen before. What a piecewise function does is this. You have different rules for different parts of the function domain. So in order to evaluate a piecewise function for a given value of x, you have to figure out which interval it belongs to, and then once you figure that out, then you can apply the appropriate rule or the definition of the function for that interval to figure out its value. So here is one where f of x is basically three different values. We have negative 6, oops, what the heck? So it's negative 6 if x is less than or equal to 1, it's 2 if x is between negative 1 and 4, and then it's 10 when x is greater than or equal to 4. So if we were evaluating this, let's say we want to figure out what the value is for negative 5. F of negative 5. Well, negative 5 is less than negative 1, so its value is going to equal negative 6, right here. If I want to evaluate 0, 0 is between negative 1 and 4, so I'm going to apply this middle rule, and so f of 0 is going to be 2. And then if I'm looking at positive 5 is greater than 4, so all numbers greater than 4, the function value is going to be 10. So when it's a single value, not that hard. But sometimes you're going to get equations. It could be any type of equation. It could be a linear equation like 4x minus 1 right here. So it's 4x minus 1 if x is less than 2. It could be quadratic. X squared plus 3 if x is greater than or equal to 2. But you're going to do the same thing. If you're given a number, like this guy here, negative 5, I'm going to see which one of these intervals it goes into. Negative 5 is less than 2, so I'm going to evaluate using the linear part, 4x minus 1. So basically we're going to do this. All right, 4 times negative 5 minus 1, that's negative 21. So the function g of negative 5 will be negative 21. And then if we have positive 5, like we do over here, positive 5 is greater than or equal to 2, so I'm going to use the squared portion here, and it's going to be 5 squared plus 3, and that's going to be 25 plus 3, 28. So evaluating these, it's not really all that tough. You just got to check which interval your value belongs to. Here we have number 1, h of x. It's 0 for less than or equal to negative 3, 2 for less than negative 3, greater than or equal to 1, or 6 for greater than 1. So we got negative 2, h of negative 2. Negative 2 is right here. It's greater than negative 3, so it's going to be 2. 4 is greater than 1, so at 4, the value of the function is 6. If we look at number 2 here, we've got 2x squared minus 1 for values less than or equal to negative 1, and 3x plus 2 for values greater than negative 1. So at negative 2, that's less than negative 1, so I'm going to evaluate using the top equation, the 2x squared. So 2 times negative 2 squared minus 1, that's 4 times 2, that's 8 minus 1, that is 7. So k of negative 2 is 7. 4 is greater than negative 1, so I'm going to use 3x plus 2. Plug 4 into 3x plus 2. 3 times 4 is 12 plus 2. K of 4 is going to equal 14. Then we got p of x. 2x plus 5 for less than 0, x squared minus 5 for greater than or equal to 0. So what would p of negative 2 be? Well, that's less than 0, so I'm going to do 2 times negative 2 plus 5. That is going to be negative 4 plus 5, that's 1. P of 4, and if you're wondering where I got these from, it's right there. P of 4, 4 is greater than or equal to 0, so I'm going to use 4 squared minus 5. That's 16 minus 5. That's 11. So you have to figure out which interval you're working under and then use that appropriate rule to evaluate the function. How do we graph these guys? It's not that hard. If you look here, we've got this piecewise function here, 2x plus 4 when x is less than 1, negative x plus 3 if x is greater than or equal to 1. They're both linear, so we're going to pick values less than negative 1, and then we're going to pick values that are greater than negative 1 or greater than or equal to, and we're going to figure them out. Now, this is the interesting part right here. What do you do at negative 1, since negative 1 shows up in both these intervals? Well, I'm going to plug in these numbers less than negative 1 to get the first part, the 2x plus 4, and that's going to be this line right here. Then at 2, I'm going to stop, and I'm going to have this open circle because I have a less than negative 1. And then I'm going to jump to the second graph, or the second equation, I should say. And the first value there, plug in negative 1, I get 4. So then I'm graphing this guy here. So I get these guys. It looks odd, because it is kind of odd, but it's really not hard. All right, so if I'm going to do this, let's do this. So I've got negative 2x if x is less than or equal to 1, and x minus 4 if x is greater than 1. So let's figure this one out. G of negative 2 is going to be negative 2 times negative 2. That's 4. We're still less than 1. G of negative 1 to negative 2 times negative 1. That's 2. G of 0. 2 times 0. That's 0. G of 1. 2 times 1. 2. Or, I'm sorry, negative 2 times 1. Drop the negative 2. But notice, this is where we get that switch, because it's less than or equal to 1, and then it's greater than 1. So I'm also going to have to figure out what g of 1 is for the second. So that's 1 minus 4. That's negative 3. And then I'm going to do the second one, 2 minus 4, that's negative 2. G of 3. 3 minus 4, that's negative 1. G of 4. 4 minus 4, that's 0. So now if I'm graphing these, let's see, negative 2 gives me positive 4. So I'm right there. Negative 1 gives me positive 2. 0 gives me 0. 1 gives me negative 2. That's where I have my closed circle. My closed circle is going to be at 1, negative 2. And then I'm going to have an open circle because the x minus 4 is when value is greater than 1 at negative 3. Right there. So I have an open circle at 1, negative 3. And then let's see what happens. 2, I'm at negative 2. 3, I'm at negative 1. 4, I'm at 0. So my lines are going to look like this. I'm going to have a line going this way. Forgive me if my line's horrible because it's really hard to graph lines. I hate it so much. All right, so there. That's my piecewise graph. I'm going down. My graph is decreasing up until the point I get to 1, and then I jump down, and I start increasing. That's basically it. You've just got to, the key here for these kinds of graphs is to look at what your interval is, and at an interval point, you're going to switch, and you've got to determine where your value is going to be included and where it's going to be excluded. And that's going to be where it's equal to or just greater than or less than. All right, that's it. That is 9-2. Smash that like button if you learned something today. Don't forget to subscribe and all that other fun stuff. And I will see you guys in the next one. don't worry if you are at home doing this online. We will talk about these lessons next week. And if you're in class, well, this is just extra for you, as always. That's how much I care. I care so much. All right. See ya.